Okay, let's try and bring some energy in the house before we can start off with the session. I would like each one of you to stand. Okay, great. Now, how many ways of clapping do you know? One way? I can teach you 5 ways, which will try and get some energy in the house. Right? Extend your left hand. Take one of your fingers. Try and clap as hard as possible. Okay, sounds good. 2 fingers. Great. 3. Louder, come on. 4. And 5. Excellent. Excellent. Please take your seats. All right, so we welcome you to day 2 and the second edition of India Analytics and Big Data Summit. While most of you have been part of yesterday's both the tracks, and I have already presented the conference overview. Having said that, there are certain new registrations that have come in today, and just for their information, I would like to brief them about what Unicom is all about and the space in which we operate. We are a global conference company organizing about 150 conferences in the space of emerging technologies, which include analytics, big data, cloud, mobility, security, agile, DevOps, next generation testing, risk management, so on and so forth. And as far as our presence is concerned, we exercise our presence in 8 countries as of now, having 2 registered offices in India and in the UK. And we plan to also expand our conference reach to 3 other geographies. So we have successfully done conferences in the Americas, in Australasia, in the entire European Union and South Africa. And of course the entire ASEAN region. And we also intend expanding our conference reach to South America, to Philippines as well as Japan. Right? So that's what we do. Some of the other services that we offer would be targeted lead generation. And apart from that, we are in the space of customer reach. And through our conferences, we enable because we line up subject matter experts, and of course, some of our target customers here would be buy-side companies, sell-side companies, and delegates that range from the practitioner level all the way to the C level. So we expect our sessions to be as interactionistic as possible, and because of which, coming to this particular conference, we have lined up certain subject matter experts and who will be, sharing certain presentations in the form of testimonials, case studies. Today we have 2 tracks. In fact, the first keynote would be a common track, which is going to be here, followed by a quick tea and coffee break, after which we will be splitting into 2 tracks. That is an industry case study track as well as a leadership track. So the industry case study track would be happening here in this very auditorium, while the leadership track happens in the neighboring auditorium. So it's more like a free foot. You can choose which track you wish to attend, and I'm very sure that most of the sessions are going to be very interesting, and I would definitely invite the audience to make it as interactive as possible and have some excellent key takeaways from today's conference. Having said that, I would like to introduce our first speaker from Intel, Mr. Milind Damle, who would be covering Intel's game-changing impact to big data. Can we have you here, sir?
And a big thanks to the whole Unicom team. It's indeed a privilege to be here to talk about what we are doing in this space. And at the end of these 60 minutes, what I hope to do is to have told you enough about what Intel is doing with Hadoop, with the open source community, and all the projects, so that you have a good understanding of where technology is headed, not just from an open source perspective, but also from where Intel wants to take it. The talk is spread for about 60 minutes. It was initially planned for 45. And what I've done is I've got some prepared presentation I'll walk you through. Then we'll play a short video. So the presentation itself goes for only about 30-40 minutes. The video clip runs about 2 minutes 43 seconds. And initially I had slotted for Q&A at the end of it. But I think looking at the participation yesterday and the number of questions people like Anurag and Vishwas got, I'd like to change the format a little bit. So I'd encourage you to stop me at any point. The presentation is split into multiple segments, so I'll pause at the right places. And the idea is not for me to stand here for 40 minutes and talk about what we're doing or what we'd like to do, but I'd like to hear from you if you have some thoughts or you have a correction. So be as interactive as Arjun mentioned. Stop me, make this engaging for both. It's a two-way street for learning, so look forward to that. In the front here, I've got almost all the Intel team that helped me with this presentation. These are the actual guys who do all the work. So Uma and Vinay work on HDFS. Anup and Ram work on HBase. Devraj works on Yarn and adapters for that. And Chinna works on Hive and Spark. So I don't have to tell about what these different projects in Hadoop are, because I guess the audience should be familiar with that. But the reason they're here is during the Q&A, we'd like to split up the answers and the questions in the format of anything to do with Hadoop, the extremely technical nature of questions. These are the guys who actually write the code that make the tools up. And anything to do with the platform, the business, and Intel's direction, I'd be happy to answer those. And we also have Soumya here. So you heard from Soumya yesterday about analytics, in particular Spark analytics, the next exciting frontier. So she's here if you have any lingering questions or opens from yesterday. Maybe you were too shy to ask her that. She's still here. And I don't think Mukesh made it here, but Mukesh is our senior technical contributor. He faces customers. As you know, we had an Intel distribution of Hadoop last year. We are actively transitioning customers over to more horizontal distributions, if you will. And he has a lot of experience with that, with customer issues, with tuning and optimization. Okay? So if you don't mind giving my team a big round of applause for all the excellent work so far. Okay, a little bit about the legal notices. I'm not going to walk through this text, obviously, but during the course of the presentation, there's a bunch of trademarks and third-party names, projects, products, which we haven't explicitly called out. So this is like a blanket waiver for me. And obviously, if I talk Windows, it's Microsoft's product. I don't need to say that. But since these files get posted outside the context, they can be downloaded and viewed, it's obligatory for me to have this page here. All right, so this is a brief outline of what I'm going to cover. And like I said, I expect this to take about 35-40 minutes. I'd be happy if it takes shorter or longer, depending on the questions and the interaction. So first, I want to set the context. And we've had enough people talking in this conference and other conferences about the 4 V's of big data, so I won't bore anybody to death with those again. But it does behoove us all to figure out where this is going and what the context today is. I'll talk a little bit about the big data platform as Intel sees it, and as we are evangelizing it, and as we are promoting it, as we are contributing to it. The software roadmap in itself is exciting. That's what these guys in the open source community does. But it's even more exciting when you juxtapose that open source roadmap with what Intel has traditionally offered, which is a very compelling server and hardware roadmap. And we'll take questions. I'm sure there'll be people wondering, well, this is Hadoop, isn't it? So it's here in the application stack. There is a Java virtual machine underneath it. Then there is the operating system in the VMM. And then there is the hardware. So why are we talking about hardware compelling innovations, and how are they relevant to Hadoop? So I'm expecting that question there. And then as all this is happening, what are some of the new trends we are seeing in data processing and data storage? So yesterday you heard from 2 or 3 panelists and speakers about, hey, just because Hadoop is making its way, it doesn't mean that RDBMS is dead. In fact, it's quite the opposite. You heard a reference from Anurag yesterday about the data lake. So I'll touch upon that. And that's where we see some of the most exciting collaboration that we are part of with the ISVs. One thing which I noticed nobody touched upon yesterday was benchmarks. So quick show of hands, how many here are familiar with TPCC? Okay, good. How many have heard about spec int? One, not bad. People are still coming in, so spec FP, linpack, spec power, come on guys, spec JBB. Anyway, quick show of hands, how many people have heard about or are familiar with benchmarks in big data? Excellent, one. And sir, can I ask if that is in the context of an end-to-end benchmark or a micro benchmark? Micro benchmark, excellent, okay. So we'll talk about the trends in big data, and for the sake of this presentation, there was a little bit of discussion yesterday saying, hey, Hadoop is not the only way to implement big data, and that's fair, but for the sake of this presentation, please, whenever I say big data or I say Hadoop, please treat them as synonymous. That's the context of today's talk. It certainly doesn't mean that the other implementations or avatars of big data are not relevant or useful, but we are putting our weight behind this particular one, and we are investing our headcount, our dollars, and our research. So I want to focus on Hadoop in particular. And hopefully at the end of it, when I summarize, you'll agree that the contribution that Intel is making is indeed going to have a game-changing impact on Hadoop, whether you call it V2, V3, vNext, Spark, or what have you. All right, so this is the overall flow of the prepared material, the presentation. Like I said, at the end of this is a video that runs for about 3 minutes. And after that, if you have any lingering questions, I'd be happy to take those. My objective is to still have you out in time for your tea break, because some people are still booting up in the morning, and others may be joining us. So want to keep it down to 10:30 and finish there. But if I did not get time for some reason, or if you had any questions after that, I'm here, I'd be happy to talk to you in person. Okay, so let's get rolling. So a little bit of the context setting, like I mentioned, and again, this picture may be a little different than what you've seen in other presentations, but the concept should not be. Data is coming in thicker and faster at us than ever before. So again, the 3 or 4 V's that we are familiar with. So on the left of this page are all the various sources of data. And some of them are throwing data at us from their proprietary systems, from standards-based systems, in formats we are familiar with, in raw format, and others. Again, pop quiz. Step back and think for a minute. If you had access to all of the music ever created by humanity, so right from the earliest cavemen grunting and doing whatever else they were doing, let's say you had the ability to create MP3s out of all of those. And I'm talking good quality stuff, okay? 320 kilobits per second. And you had the ability to store all of those as recorded music. How much storage space do you think you would need? Going back all the way from the first song to today. Yes, including Katy Perry and Justin Bieber and all those guys. Anybody want to hazard a guess? I'm sorry? More than petabytes, okay. Anybody else? I'm going to stand here silent until I get at least one more estimate. Good. Could you be more specific? Throw me a number, it's fine. By the way, no prizes, just a pop quiz. Excellent, 10 terabytes. Again, I'm not asking for a justification of your number, right? Just throw me any number. More than tens of thousands of petabytes. Okay? Because humanity has always done a lot of music, is what you're thinking. Okay? Again, I'm not trying to diss any particular answer, but recently I read an article that if you were actually to do this automagically, if you had access, the amount of storage you would need to store all of this song or music would actually cost less than $1,000, less than 1,000 US dollars. And that's at today's dollars per terabyte, whatever SATA speeds you have, or whatever density you have. So sit back and think about that. For example, your estimate was way off. Again, nobody can prove this with certainty. You may well be right, but there is some math that these people have employed to arrive at that number, right? So you, sir, are closest. To my knowledge, the closest price point that I've seen at retail, by which in the US I mean if you walk over into Staples or Costco, you can buy a 4 terabyte SATA drive today for about $120. And again, this is the landed retail cost. So if you're a Facebook or a Google, obviously you don't pay that much. You pay, I don't know how much, but less than half of that for sure. So at $100 per 4 terabytes, I mean, you can do the math. Some estimates go as low as $500. So it's probably safe to assume that everybody in this room can afford a $500 set of drives. So think about it. Each one of you could potentially have all the music ever produced. Now, you don't probably want that, but the comment I'm making is where storage is headed, it's effectively at scale, at volume, it's free. There was an interesting question somebody in the talk asked yesterday. How many of you really spend a lot of time deleting and managing your Gmail accounts? Or if you don't like Google, your Yahoo accounts or something else? Okay? And do you do that because you like to keep it clean and tidy, or? Okay, so it's a preference thing, good. As spam filters have become better and better, usually I find that my inbox is not cluttered with, make money off the internet, work from home, or some of the other stuff that they want to sell me medicines and, other nasty stuff. Once in a while they do miss those. But my point is, it's become redundant to spend your time into chasing, pruning, and trimming these things. Same thing in the enterprise world. It's become cheaper to just store all of your data. Now, whether it's sound policy or not is probably an individual preference or a corporate IT preference. But it's cheaper to store all of your emails, archive them intelligently, back it up, than to pay lawyers at $400 or $500 an hour to tell you which emails to retain and which ones are safe to delete in the event of a lawsuit. It's a little hard to wrap our minds around this concept that effectively as storage becomes free, you can just simply retain everything. And in a way, in this space, that's where technology is taking us. As all of this data is coming into our various systems at scale, by which all the internet portal data centers, they are choosing to keep everything. Anybody try to delete their Facebook account? Okay, one. Were you successful? There you go. It's like Hotel California. You can check out any time, but you can never leave. What's more, even if you delete your account successfully, even if you were to say, I don't like this tremendous amount of data donation I'm doing to these companies. I don't want my kids' pictures there, or maybe you have some embarrassing pictures of your past life. You think you have deleted those, but they are not actually gone. Now think about it, why? If you're Facebook, your user is telling you, remove me, remove my content. Now, all of us know technically it's trivial, right? If you were in Facebook's shoes, you would do it. You could do it, but they don't. And the point is, they are trying to monetize you as a product. You are the commodity, you meaning the consumer, not individually you as a person, right? And so it's cheaper, simpler, better. What if you changed your mind and decided to rejoin? Without belaboring the point, where I'm going is it's easier, cheaper, and better for us to keep it. In the event we need to run analytics to predict future directions, and that's exactly why they're doing it. Now, unfortunately, that's the more nefarious scenario I painted. Not all the companies, not all the use cases are as vile as that. There are genuine reasons why we might want to choose to retain all of that in the event that there are future advances in medicine or algorithms where you can go back on that data. So for example, I'm sure you've heard about all the recent activity in Africa around Ebola. Simply having access to all of that data 20, 30 years from now might yield us to develop a killer vaccine or some